Hello everyone. Let me show you the logic of converting an integer number into its octal equivalent. The logic is on the same lines as of the immediate previous video where I converted an integer number into its binary equivalent. So when any number is divided, modulo divided by say 8, the possible remainders go from 0 to 7. So if it is divided by 2, the modulo division by 2, then the possible remainders are 0 and 1. So in general, if any number is modulo divided by n, then the possible remainders are 0 to n minus 1. And that is the remainder that you have to capture in the reverse order. So as you modulo divide a number by n, capture the remainder and add it to the beginning of the string. So at the end, the string you generate would be the octal equivalent of the number. So the logic as it is with the previous one, we are going to first thing do is convert the number into its integer. Okay, so the first thing we will do is we will convert the number into an integer and check whether it is an integer or not, because if it is not an integer and it contains a fractional part, then we will have to apply a different method. So if it is not an integer, then we would show a message saying not integer. Otherwise, we are going to do our logic here. So the first thing we'll do is create an octal variable, which is an empty string. And to this empty string, we are going to prepend the remainders that we obtain. So the first thing we'll do is till b is greater than 0, we are going to apply the logic of extracting each character and prepending it to the string. And once we are done with the logic, at the end, we will generate the output. Okay, so what we will do is we'll find the remainder by modulo dividing the number by 8, and we will also update the original number by dividing the number by 8. And finally, we will be constructing our octal string by prepending the remainder. So that should be the logic for converting an integer number into its octal equivalent. Let us try. So if I enter a 12, I should get 12 modulo 8 is 4, and then again 4, 1 modulo 8 is 1. I should get 1 and 4. Let us see. Okay, so that's the octal equivalent. So you can go ahead and try for any number. So that's 144. You can try this out. Use a calculator and calculate and see whether you're getting the same values or not. So try this logic out and we'll catch up in the next video with the hexadecimal conversion.